Today we will discuss how to use Proteus for simulating your stepper motor program, Part B experiment. So those who are having the softwares Proteus and Keel development kit or package, you can do try this. So we will begin with the steps. So first we will create a schematic. So go to File, New. Here select the directory where you want to create your Proteus project. My case, I'll be using a folder Proteus, and this would be my root folder. And let me name the project as stepper 2. Give next. So we are supposed to create a schematic. Give next. Then no need to create PCB, no firmware. So schematic is checked, other tools are not check marked. So finish. So I'm gonna get schematic now. So according to the part B experiment stepper motor, we know that we will be using a motor driver ULN. So we require ULN. Controller we require, we will be using LPC2148. Now cell we will be using, and also for this we will try to use a crystal oscillator which is running at a clock frequency of 12 megahertz, which happens to be your clock frequency of your Cortex M3 microcontroller. So let's pick all the components. So first I'll be picking LPC2148. Just type LPC. I'll get different makes of LPC. I'll be picking LPC 2138, which is approximately equal to 2148 machine. Let me lay that component over here. The second component which I'll be picking is your motor driver ULN2003A. So you got that component over here, 16 pin IC. Use it. Okay, so from microcontroller we're gonna give the input to this motor driver, and we will take the output from this driver, and we will be feeding it to stepper motor. So next, pick the stepper motor output module. Stepper motor, you have two types: bipolar bi-stepper motor and unipolar stepper motor. I'll be picking unipolar stepper motor. So this is having 5 or 6 wires. 2 are meant for supply, and 4 are meant for coils. So first pin, second pin, third pin, and fourth pin, in that direction you need to connect. And this the middle coil over here, left side and right side, has to be shorted, and it has to be connected to motor supply. So motor supply, we will give it as 12 volt. Now a few more components we require. Crystal oscillator. So just type crystal. So you pick crystal device, quartz crystal device, place it over here, and we will try to rotate it by 90 degree clockwise. Then connect the two ends of this crystal clock oscillator to the XTAL1 and XTAL2. Then parallel to this crystal oscillator, connect two capacitors with the values as 22 pico, and select while selecting subcategory for the capacitor, go to ceramic disc, and in this ceramic disc you pick ceramic 22 picofarad. 2 I need, and this 2 has to be connected parallel, it has to be connected to this oscillator. And finally use the terminal node, ground, and the other connection, this terminal has to be grounded. So this is for tuning your frequency, increasing or decreasing it to a bit lower end. Then we use the single battery which we required. So go back to your component mode, and here I'll pick the cell single battery, and this cell cell, and it has to be connected to P battery, ground to VSS, one more wire, this should be shorted, So this is the connection onto the left hand side. Right hand side, we will make use of port 0, P00, P01, P02 and P03. In your part B experiment we had used port 2. So here we will use port 0 connected to the 4 terminals of your driver. After connection, the output of this driver should be connected to the stepper motor. First leg, second leg to 2C, third leg, this one goes to 4C, and this one goes to 5C. Sorry, I made a mistake. This should be removed and it should be connected to 3C. 3C is here and this should be connected to 4C. Okay, and these two terminals short it together and connect it to the motor driver supply. So motor driver supply, you can go to this generator mode. You have different sources. DC supply I'll take and I'll drop it down here. Okay, this is the motor supply. So the value to be given to this motor supply could be changed. So what I'll do is I'll just make this as 12 volt. Double click here, can give any name, motor supply or VSS, and let me provide the voltage as 12 volt and give OK. And from this point I'll be connecting this terminal to this end. Okay, yes. Okay, one second. Okay, this connection is created now. VSS is connected to this two ends which are shorted, and it is given to VSS which is set to 12 volt. After doing this, we will connect this, give a supply voltage. So go to terminal node again, node this option. So here select the power button and connect power, that is the supply voltage for this IC to 9. Okay, so hope this is okay. Now let's hope these connections are fine. So I repeat, capacitors you require, crystal oscillator you require, controller you require, ULN driver you require, ULN driver supply voltage you require. It has to be connected to your stepper motor, and for this to drive this IC you require a power voltage of VCC of 5 volts. So this is the connection. So after this we will save the schematic. Once it is saved, let me go back to the key environment. So here we create a project, new project, and here we will name the folder where we want this project to sit. Stepper 3, and go to this folder give the folder project name, step 2, save. So I'll get this option. Now select NXP, in NXP LPC 2148. Give OK. Now copy the startup file onto the project. Then go to the file. So here you can copy and paste your stepper motor program. I'm already having it. So this was your stepper motor program. So Control C, go back, paste, and modification already. What we need to modify happens to be this frequency. The microcontroller has to be modified here. 2.1 I'll be using, and no change. Let's just, for the time being, instead of 1, I'll just make this as 50. Otherwise, to some extent, it will it will rotate, but difficult for us to view what's happening. So 50 I'll set the values, and few more things which I need to modify. Since I'm using port 0, IO directional 0, then this should be IO directional IO pin 0. Now I'll copy this, Control C. So everywhere the same command has to be pasted in front of this. V. So this should rotate the your stepper motor in the anti-clockwise direction. Let us see whether it has been done or not. So first add this file, save as the name step.c. After saving, add this .c file onto the project. You've added, close. Now build this. Before building, go to project output and select the option target 12 megahertz, that's 10. Then create X file. Then again go back to linker and select this check mark on this, use memory layout. Keep OK. Next we will build. Fine. Then we will rebuild. So now you're gonna get a hex file. So we will use this hex file and we will dump it on this IC. Now let me double click on this. Go to the project which you have created. So it is in ARM, part B, stepper 3, and this is the hex file which is created just now, 1035. Yeah. Load it. Mega frequency you set it to 12 megahertz. Give OK. Now we will run the program. Simulation error. We'll see what was that mistake. Okay, battery should have been changed to 3.3 volt. We have not modified the battery, so this battery setup has to be modified. So connect, double, just go to this 5.5 volt here, make this 3.3 volt. Okay, now we will simulate. Okay, the stepper motor is rotating in anti-clockwise direction. It is a bit slow. You can vary the delay and you can figure out what's happening. Thanks for watching the video.